Hello, everybody. This is Mr. Gisondo again. I'm pretty excited today because we get to do 9-5. We get to do completing the square, and completing the square, one of the best sections. So I'm pretty excited today. I've got my Mr. Buffard shirt on also. If we can see that, kind of. But I'm excited because we get to do completing the square. So today we're gonna learn how to complete the square. That's our lesson vocab for today. Let's get into it. So the first thing we get to do is a little bit of critique and explain. So Enrique and Nadim, they solved this equation. They did it two different ways. So part A says to critique Enrique's work. So if we look at what Enrique did, he took x squared minus 6x plus 9 equals 16, and it looks like subtracted the 16 from both sides. So that looks pretty decent. So it looks like we're going to do our zero product property. Factored, does that factor correct? Yep, looks like he factored correctly, so that's good too. Then we set each parentheses piece equal to 0. Did it. Correctly added, correctly subtracted. I'm going to check him off. He looks like he did a pretty good job. So here, Enrique did the zero product property. And that was all the way back from section 9.2. Next, we could look at Nadim. So what Nadim did is, looks like he took this side and he just factored right away. I guess that's okay. There's no rule against it. So does it factor into x minus 3, x minus 3? Yeah, okay. So it looks like there's some factoring, so that's good. Had equal to 16, and then it looks like Nadim did square root of both sides. So it looks like Nadim did it like we did last time in section 9.4. We're solving everything by square root. So we have plus or minus 4, and then added 3 to both sides, hopefully. So split it up into two solutions. Then at 4 plus 3 is 7. Negative 4 plus 3 is negative 1. So yeah, I'm going to give him check mark 2. So it looks like we got two good answers with two different ways to do it. So then it says to use structure for part C. Can we use that to solve this quadratic equation? Well, all right, let's check it out. So we said Enrique was doing the zero product property. So for his way to do it, we have to make sure we equal 0 first. So we can subtract 3 from both sides. That's pretty solid. We get 22. Then we have to go ahead and factor. So when we go ahead and factor, since x squared is just by itself, we can just make the chart, find our factors, and just write our answer from there. We need to multiply to 22. We need to add up to 10. I don't know, so I'm just going to go ahead and guess 1. Best thing to do if you don't know. 1 times 22. If I add that up, I get 23. That's not good. So we'll try 2. 2 times 11. If we add that up, we get 13. That's not good either. 3 won't work. 4 won't work. 5 won't work. So it looks like he can't do it. So Enrique's out. So unfortunately, we cannot use the zero product property to solve it. But maybe that's okay, because maybe Nadim can't solve it either. Because if Nadim can't solve it either, then maybe this is just one of those that we got to put into Desmos or a graphing calculator and solve by graphing like we did in 9.1. So let's see what this method takes us. So we get the same start. And so we have to factor this part. So that says, okay, instead of doing 22 and 10, we're going to pick 25 and 10. I think I know this one. I think this one's just 5 and 5. So we're going to split this up into x plus 5. And since it showed up again, I'm going to write it like Nadim did. Instead of doing x plus 5, we're going to do x plus 5 squared. So let's see. Remember, this way we're doing solve by square root. So I have to square root both sides. So x plus 5 equals plus or minus the square root of 3. Nadim split it up into two equations next, so I'll do the same thing. So x plus 5 equals square root of 3. X plus 5 equals negative square root of 3. Subtract 5 from both sides. So we get x equals negative 5 plus the square root of 3. And x equals negative 5 minus the square root of 3. Well, we got two answers. Well, that was pretty decent. They don't look like they're super friendly answers, because they're not integers, they're irrational. But that's okay. We saw that those could come up when we're solving by square root. So it looks like this one does work out. So it looks like the square root property, Nadim's got the right way to do it this way. So that's kind of cool that we could solve this one way, but we couldn't solve it the other way. So that's kind of what we're going to do today. So today we're going to look at solving with completing the square, which is going to be mostly using something like Nadim's method to solve ones that we can't factor. So that's kind of nice that we can actually solve them by hand. We don't have to go to the calculator. So we're going to check that out. So that brings us to example 1, where we have to complete the square. So this is it. This is the big thing. We get to find out what value of c makes x squared plus 6x plus c a perfect square trinomial. All right. That means we're making a square. So it looks like they gave us some algebra tiles. So I'm going to say, if I have to make a square, I've got my x squared and my bx. Let's make a square out of it. That there. Set my transparency so that it looks a little bit nicer. All right. There we go. Looks like a square. All I need to do is I just need to fill in this part down here. So if I know what I can fill this part in with, I should be good to go. So I know that this is x squared, and x squared is x times x. So if I'm working backwards with factoring, let's see, bx divided by x is b. Bx divided by x is b. So let's see, that needs to be b squared. But I got a little bit of an issue, because if I think about b might be like all of my tiles over here. I don't want to use all my tiles because I split my tiles up into 2 piles. So that means instead of this being kind of like my b, I need to split it up, because I need to take half of them and half of them. So instead of b, it's going to be half of my tiles. B over 2, b over 2. So this is going to be b over 2, b over 2. So this isn't going to be b squared, it's going to be b over 2 squared. So that's what I have to have. So I made a square, so that's good. That's the goal, we want to make a square. So if I have to think about what number I'd have to add, well, I've got my number, and I don't want that. I know b is 6, but I want to take half of that. I want b over 2. It's 3, and then to get my answer, to find out how many squares I have, little tiles I have to add, I need to square that to get 9. So if I add 9, I should get a perfect square trinomial. I'm going to pick 9 for C. So can we check it out? Does it work? Well, let's try it out. X squared plus 6x plus 9. If we factor it, we have to multiply to 9, add up to 6. 3 plus 3 is 6. X plus 3. X plus 3, which is x plus 3 squared. And that is a perfect square trinomial, because it doesn't have any little extra parts onto it. We just got our one binomial squared. That's it. That looks like we're pretty good. So that's our goal. So if you want a visual, the visual to keep in mind is what we're doing is we're making squares. So I'm trying to make squares out of the pieces that we're given. In this case, we're given x squared plus 6x. To make it into a square, I need 9, because that would make me a full square. And that's our goal with completing the square. So that's what our vocab is. So when we complete the square, what we're going to do is we're going to add a number to create a perfect square trinomial. So that's going to be what our vocab word for this unit, this section is. You'll notice it says add. So we're always adding. We're not going to subtract. We're always going to add a number. That seems like it's a little bit strange that, most times in math you could add or subtract, but in this case we only want to add. We're just going to do some adding. So if we try it out, we got the try-its. Again, feel free to pause the video and give these a go. But to find out what value of c completes the square, for the first one, we know b is 12. When we cut it in half, we get 6. b divided by 2 squared is 6 squared, so I get 36. I don't need to check it by factoring or anything like that. We just want to find out what the value of c is. We'd have to add 36 to this part to complete the square. For this one, b is now 8. b over 2 is 4. Square that, we get 16. So those are our two values that complete the square. That's it. That's pretty fun. I like this part. All right, so we've done it. We got our perfect square trinomials. So now we know how to get our perfect square trinomials. Now we have to use our perfect square trinomials. So we're going to use this to solve some of the quadratics. This is going to be like Nadim did. So we got a little bit of a thing, though, because we can't just factor this right away. We are going to use completing the square in order to make our equation look like Nadim's equation. So first thing we got to do is realize we got a nice trinomial. We have to identify what b is. Remember, b is always the middle term. It goes a and then b and then c. So in this case, we need to identify that b is negative 14. So we do get to keep the sign here. When we divide it by 2, we get negative 7. When we square it, we get 49. So remember, when we want to make a perfect square trinomial, we always wanted to add a number. We always wanted to add the 49. So this is going to become x squared minus 14x plus 49. That looks good. That's what we did in the last part. That's what we did in example 1. But we're not allowed to just add 49 if we want. If we add 49, we also have to take away 49. And the rest of the problem still exists. So we still have the negative, so we still have the plus 16, we still have the 0. But the reason that we wanted to do this is because we can take our sum here and turn this into x minus 7 squared. Now you may think, wow, you factored that really quick. How did you factor that so quickly? The answer is I did not factor it, because that's the whole reason we complete the square, so we don't have to factor. If we look over here, b over 2 is negative 7, and that's where my minus 7 came from. So I didn't have to factor anything. So if you don't really like factoring too much, you might like this a lot, because it kind of bypasses all the factoring we had to do. We still have the rest of the problem to work with. We got negative 49 plus 16. That's 50, 40, 30, 35. We're going 35. Nope, 33. 33 plus 16 will give me 49. Equals 0. And so we can't use the zero product property here. Even though we have 0 on one side, we don't have a whole trinomial anymore. So we want to solve this one like we'd solve our square root ones from the last section. So we want to add 33 to try and get the squared part by itself. So x minus 7 squared equals 33. Square root both sides. So we did a good job with that last section, so we're going to square root both sides. X minus 7 equals plus or minus square root of 33. And then we're going to add 7 to both sides. Plus 7 plus 7. So x equals 7 plus or minus the square root of 33. Now you're welcome to split that up into two parts. So you can split that up into 7 plus square root 33 and 7 minus square root 33 if you want. Or if you want to type it into a calculator to get a decimal equivalent. But that's an exact answer, and I'm pretty happy with that. That's why I like this part, because like that looks really clean. You don't have to have all those crazy looking decimals. That's just it. We're done. So refreshing. So that one was fun. If you want to try the try-its on your own, give them a go. So you can try the two try-its out. Bring that one on screen. So you can try these ones out. They should be as fun as the last one. But we're going to go through them real quick. So with this one, again, the whole goal is to recognize that b is 10, b over 2 is 5, b over 2 squared is 25. So we get x squared plus 10x plus 25 minus 25 minus 9 equals 0. X plus 5 squared minus 34 equals 0. X plus 5 squared equals 34. X plus 5 equals plus or minus the square root of 34. Need a little bit more space. X equals negative 5 plus or minus the square root of 34. It's cool. You get to get an exact answer, so you don't have to use those decimals. I like it. I think it's fun. This one, again, so we got b is negative 8. All right. B over 2 is negative 4. B over 2 squared is 16. So we get x squared minus 8x plus 16 minus 16 minus 6 equals 0. X minus 4 squared minus 22 equals 0. X minus 4 squared equals 22. Square root, x minus 4 equals plus or minus root 22. X equals 4 plus or minus the square root of 22. That's it. This section is so fun because you just kind of get to use your process and just kind of follow it down. It's so good. And we didn't have to factor. So we got our answers without factoring. I didn't need to use Desmos or anything like that. We can just kind of drill it down. So it's kind of nice. So we can also do it when it is a little bit more complicated. So if A is not 1, the rules have to change a little bit. Because in order to do this process, we do need A to be 1. So we just need an x squared by itself or a w squared by itself. That's the one downside with this method, is that does have to be by itself. So in this situation, we got a word problem with a hedge maze. So it tells us that the hedge maze has a 2-yard wide walkway around it. What are the dimensions of the maze? All right, so we know that this is like 2, 2, 2, and 2. And we're also told that the length of the hedge maze is twice as long as the width. So this is like 2 times the width, and that's the width. We've got that, and we've got that. So we're also given the total area, so at least it looks like a rectangle. So we got our good friendly rectangle formula. Area is the length times the width. So that means that the area is going to be, the length is going to be 2w plus 2 for each edge. The width is going to be w, and then I got 2 up here and 2 down here. So not 2w, just regular w. So w plus 2 plus 2. We're also given the area, so I'm going to make my substitution now. The area is 5616. So they tell us that that's the total area. 2w plus 4, and this is going to be w plus 4. So we have to find the dimensions of the maze, so we're trying to find w. Okay, so in order to complete the square, the first thing we need to do is make it look like it's in standard form. So let's get that going. 5616. I'm going to multiply those binomials together. That's going to be too small. So 2w plus 4, w plus 4. So 2w squared, 4w, 8w, and 16. We'll combine the like terms. So we get 2w plus 12w, 2w squared plus 12w plus 16. And I said that you have to get that w or that x by itself. So in order to do that, looks like we're going to have to divide everything by 2. And that's okay, because we did that before when we were looking at our GCFs and trying to simplify our factoring process. We learned to kind of try and get rid of our GCFs and divide if we can to make the numbers smaller. So that's not really new. 5616 divided by 2. So that's 28, and then another 8. W squared plus 6W plus 8. All right, so it looks like now we got W squared by itself. It looks like I'm ready to complete the square. So I'm going to go ahead and complete the square now. So first thing I want to do, what's B? B is 6. What's B divided by 2? 3. What's B divided by 2 squared? 9. So 2808 equals W squared plus 6W plus 9 minus 9 plus 8. All right, need some more space. Okay, so that looks good. So now we kind of drill down a little bit more. $28.08 equals W plus 3 squared minus 1 when we combine those like terms. All right, so I want to go ahead and try and get this squared piece by itself, so I can add 1 to both sides. So 2809 is W plus 3 squared. All right, square root both sides. Do we know the square root of 2809? Yes, we do. 2500 is 50. Add 300. 3 squared is 9, so 53. That was easy. W plus 3. Subtract 3 to get the W by itself. And so now we have negative 3 plus or minus 53 equals W. Now, since this is a real world problem, we do want to get like our final answers to be separate answers. And if there are any decimals or fractions, we do want those. Because again, if we were going to build the hedge maze, we'd probably want those actual decimals. It might not be easy to build a hedge maze knowing something's a square root value. So we do want to actually go ahead and keep going with this. So we get negative 56 if we subtract. Negative 3 plus 53 is going to be 50. So if I'm building the hedge maze, I have to decide, do I want my width to be 50 or negative 56? Well, widths can't really be negative, so we're going to get rid of the negative answer and say that W equals 50. Now, does that answer our question? Let's check it out. What are the dimensions of the maze? Well, we know the width. So we also need to get the length. But we said that the length was 2W. So 2 times 50, where the length is 100. So our dimensions are 100 by 50. Or 50 by 100 if you want to say the width first. So that solves our maze. We found our dimensions. That was cool. We didn't even need the calculator. Even though we had all those giant numbers. This one's just so, I like this. All right. Regardless, we're going to go ahead and check out another hedge maze. This time, though, our walkway is only going to be 1 yard wide. So what we're going to do is I'm going to draw a nice little picture. So again, same deal. So we're going to have 2W and W again as just the maze. And then we're also going to go out 1 for the walkway. So when we make this expression, we're going to get again 5616 is equal to, in this case, length times width is going to be 2, that's a 3. 2W plus 2 times W plus 2. So again, I'm going a little bit faster than the other example because we already seen how to do it fully out one way, so we're going to kind of go a little bit quicker. Until we realize, well, when we multiply, 5616 equals 2W squared plus 6W plus 4. Divide everything by 2. And we're going to see everybody's least favorite thing to see when they complete the square. 2308 equals w squared plus 3w plus 2. Nobody likes seeing an odd number for b. That makes things a lot more complicated. So b is going to equal 3, which means b over 2 is 1.5, and b over 2 squared is 2.25. So if we think about our mathematical justifications, we probably wouldn't choose this method. We would not use it. So thinking about using our method strategically, we see that decimal, and that decimal is just not going to make me happy. At this point, if I was actually solving the problem, I would probably then use the graphing method, because I could see this method is going to give me some decimals, which I'm not going to be too happy about. I'm probably going to have to take the square root of decimals, so I'm going to need a calculator anyway. I would probably shift my focus and say, all right, I'm just going to take my equation that I have right now, subtract 2308, and find the zeros graphically. But let's be intrepid. Let's keep going. Let's see where this takes us. So 2308 equals w squared plus 3w plus 2.25 minus 2.25 plus 2. So 2308 is w plus 1.5 squared minus 0.25. Add 0.25. So 2308.25 equals w plus 1.5 squared. Yeah, so at this point, I don't know 2308.25 square, the square root of that. So I'm stuck with going to the calculator. So let's just see what we get when we put in the calculator, because unfortunately, that's kind of where we're at. So if I do that, oops. I get 52.995. That's going to be about 53. Considering I'd have to build the hedge maze, I'm just going to say that that's about 53. W plus 1.5. So again, I probably wouldn't worry with all the decimals, because if I'm going to be off by 0.005 feet, that's only going to be a couple inches on a giant hedge maze. So I think I'm going to stick with 53. So this doesn't make it too bad, because we can subtract 1.5 again. And get negative 1.5 plus or minus 53 equals w. So that's going to give us, when we subtract negative 54.5, and we know we don't want the negative one, but it's good to see it. And then 51.5, if I add those, so I don't want that. And then just like last time, we want the dimensions. So the width is 51.5. 51.5 times 2 is 103 for the length. So my dimensions are going to be 103 by 51.5. And if I was actually solving it, probably would just go ahead and graph it. All right, so example 4 is going to show us something handy that we can use completing the square for. It's actually going to convert us from standard form to vertex form. So if you remember all 3 of the forms that we had, this is kind of the one missing link that we haven't had yet. So we've gone from factored form to standard form by multiplying binomials. We've gone from vertex form to standard form by basically, again, multiplying binomials. We've gone from standard form back to factored form by factoring. So this is kind of the last missing piece. We're going to use completing the square in order to get to vertex form. So again, we get to have some fun. We get to find out b is negative 8, b over 2 is negative 4, b over 2 squared is 16. So the only difference really between what we've done before and this one is that we have this y here, and that y really doesn't do anything. It just kind of hangs out. X squared minus 8x plus 16 minus 16 plus 11. I've got negative 4 for my b over 2. So x minus 4 squared. Nay, that's going to be minus 4, and we're done. That's it. We have vertex form. So that's our vertex. So our vertex is going to be positive 4, negative 5. That's it. That's all we have to do is just a nice little completing the square. Again, I think it's fun because it's a lot easier than factoring, a lot quicker. And that's it. So for the triads down here, give them a go if you want. Try them out on your own. But we're going to find the vertex form for each function. So for A, we find out what B is. B is negative 2, not negative 2x. I don't want the x. Divided by 2, we get negative 1. Square it, we get 1. Y equals x squared minus 2x plus 1 minus 1 plus 3. Y equals x minus 1 squared plus 2. That's it. Done. For this one over here, b equals 6. Oh, we've done 6 a lot. B over 2 is 3. B over 2 squared is 9. Y equals x squared plus 6x plus 9 minus 9 plus 25. Y equals x plus 3 squared plus 16. Done. That's it. So that one was pretty quick. So yeah, once we actually get the process down, it goes by really fast. That's going to bring us to the last example, example 5. This is an application one. So again, the applications aren't always going to come out so nice. So sometimes you have to think, is it going to be easier to do it with completing the square, factoring, or graphing? So you got to make your decision with some of these ones depending on how you feel about the numbers. So in this case, our example we have is our astronauts are going to train. So we get to do the flight path of this airplane that flies in a parabolic arc. The graph shown approximates the altitude in meters of the plane in relation to the time t seconds during a training session. What's the maximum altitude reached by the plane? At what time does the plane reach its maximum altitude? So since they're going for the maximum, that tells me that they want the vertex. So again, I'm thinking that if I was actually doing this, I would use my tools and I would say I'm probably going to just graph it. But let's see how to do it by hand. So I've got my equation down here. They gave that to me. So I know that A is negative 5t squared plus 80t plus 9,000. And that makes sense. Our parabola is upside down, so we should have a negative there. So I know to complete the square, I have to make sure that my x squared, my w squared, my t squared is just by itself. So I need to divide everything by negative 5. Okay. Well, I have to divide this side by negative 5 also. Unfortunately, we can't really do anything with a divided by negative 5 except just leave it as a divided by negative 5. T squared, that's going to be minus 16t, and 9,000 divided by 5. Well, 9 divided by 5 is 1, 40 divided by 5 is 8, and we got a couple zeros. All right, so that part on the left looks weird, but other than that, I think we're good to go. We find b. B is going to be negative 16 divided by 2, negative 8, square it, 64. A over negative 5 equals t squared minus 16t plus 64 minus 64 minus 1800. Okay, even though this still looks weird, we don't really do anything with it. We just kind of leave it alone. So we get t minus 8 squared, and then that's going to just be, okay, well that's nice. That's just minus 1864. That's not too bad. So we're close. We've almost got it in vertex form, but we still need to make this minus 5 kind of go to the other side, because when we have an equation in vertex form, we want the y, or in this case the a, to be by itself. So instead of square rooting both sides, I'm going to multiply both sides by -5. So to do that, I have to distribute this -5 to both pieces. Now you notice I said both pieces, not all three pieces, because this is kind of stuck inside the squared. So with PEMDAS, with our order of operations, we can't do anything with that. So that just kind of stays out front. So that's that part. -5 times 1864. Do not know that one off the top of my head. I'm going to have to actually multiply that one. 4 times 5 is 20. That's going to be 32. 43. 9. So 9320. And then negative times negative will make that a positive. Probably would have been easier to do 5 times 64, because that is 320, and then add that back up to the 9,000, but we did the whole way out. So I've got the equation in vertex form, so that's good. So we know the vertex is going to be at 8, 9,320. So that's a good math answer, but since this is a real world question, we want to answer that in terms of the problem. So if we think about this graph, t is where x usually is. So that means it's going to reach it at time 8. But 8 what? Well, over here if we look, t is in seconds. So this airplane is going to get the highest it's going to get after only 8 seconds in the air. And if you think about it, I mean, that seems like that's appropriate for like a space shuttle. It should go up really quickly. We want to find out what's the maximum altitude though. So for that, we'll say that the altitude A, I forgot what number we had, 9320. And that's going to be in meters. And this is going to be where it's at the maximum altitude. So that the airplane is going to get up to 9,320 meters. That's pretty big. So that's going to be what we want for our result. So you can see we can get our vertex form. That was good. That wasn't too bad. But if I was doing it, I might go with the calculator with those numbers. They were kind of big. We can try it out. For the try it, now we're just doing the math example. We're not doing a real world application. So first thing we want to do is see that I don't have x squared by itself. So I have to divide everything by 7, which again, we might not like 7, but y divided by 7 is perfectly fine. We can leave it alone. 168 divided by 7, so that's 2 and 4, 24. 105, that's going to be 1 and 35 is 15. Okay, let's just jump in. B is 24. B divided by 2 is 12. Square that. We get 144. All right, so y divided by 7 equals x squared plus 24x plus 144 minus 144 plus 15. All right, y divided by 7 is x plus 12 squared. 144 and 15, so that's 134, 129. All right. Next step we got to do is, again, we don't move the 129 over because we're trying to get y by itself. That's the end goal. So we got to multiply by 7. So we distribute the 7 to both pieces. So 7 times x plus 12 quantity squared. And we got to do 7 times 129. So again, this is going to be one that I just have to kind of do by hand. So it's 63. 7 times 2 is 14. 14 and 6 is 20. 7 and 2 is 9. So 903. Okay. So I know that the vertex is now at -12, -903. So let's make sure we answer the question. Find the minimum value of the function. So when they say minimum value, they're looking for the y value, not the x value. So the minimum value is at negative 903. Because the value is going to be the output, not the input. So the only thing I need is the 903, negative 903. All right. So nice thing is that's the last example. And we could do that one by hand. Again, you might want a calculator for like this part, but that actually didn't turn out to be too bad. I might actually prefer that one to the calculator. It might take me a little bit longer to actually find that minimum because that's a really small number. Like I'd have to zoom way out and then kind of mess with it. So I don't know, kind of equal on this one if I would go with the completing the square or with the graph. But that brings us to the end. So in general, we did completing the square today. It is a process. It's a new process that takes a little bit of time to get used to. So you might not get it after the first try or the second try. But once you kind of get the hang of it, it gets really easy. So that's what we want to do is we want to find out essentially what we're adding here to form a perfect square trinomial, which is always going to be b over 2 squared. So that's the idea is you want to do the b over 2 squared. To solve it, if you want, in Pearson, they say you can add 49 to both sides. I like just doing plus 49 minus 49 because it looks kind of the same every time you do it. But you're more than welcome to add 49 to both sides too. The other thing is our answers when we do it this way, they're in exact form, not decimals, not fractions. Unless we have real world problems, then you want to actually change those into decimals or fractions because that's what you actually work with in the real world. So that's it with this one. I like this one. This one's one of my favorites. It does take a little bit of time to get used to, but once you get used to it, it's really fun because you can just kind of fly through them. So that's it. Have a good day. Have a good week. And again, if you have any questions with anything, make sure you email your teachers, show up to the live sessions. Have a good day.